This conference will now be recorded.
So, good morning, everyone. I'm Srinivas. So, today we'll be starting off with the USB 2.0 core system Verilog and UVM verification course. We will divide this course into two aspects. One is the understanding of the USB protocol, and other will be the functional verification of the USB 2.0 core. So initial 1 or 2 weeks will be spent on understanding of the protocol, followed by working on the core verification. Okay, so this will be the agenda. There are two slides of agenda. One slide focused on the understanding of the protocol, different aspects of the protocol. What you see here, the 2.0 basics, the topology, connectors, the USB 2.0 features, the device descriptors, line states, the data transfers, what is USB functions and endpoints, endpoint types, different types of packets and USB packet types, low speed transfers, full speed transfers, high speed transfers, UTMI, USB core operation, and core interfaces. I I understand probably you didn't get much of it because we haven't gone into it. I just read through the USB 2.0 protocol training agenda. As we go into the protocol, you will get a better understanding of what we are talking about. Second will be focused on the second part of the training, as I said, will be focused on USB 2.0 core functional verification using system log and UVM. We will be working on the entire flow, starting from reading the design specification. I mean, how do we start with the design specification? How do we read it, and how do we list down the features? Let's say, given a design specification, how do we understand the architecture, what all interfaces are there, what all registers are there, what all subblocks are there, how do we understand. Then we learn how to develop the verification plan and test plan. I mean, how to list down features and how to come up with the test plan. Then we'll be working on how to list down the functional coverage points. Then we'll also work on developing the test bench architecture. USB 2.0 is a little complex design with two master interfaces, so hence test bench architecture will be a little complex. Then once the architecture is developed, we will learn how to develop the test bench components and how to integrate them. Then we'll work on register model development and integration. I mean, how do we develop the register models and how do we integrate? This is one important concept which is applicable in every project. Any project you get into, any kind of, I mean, whether it is module level verification or subsystem level verification or SOC level verification, you need to work on register model development, and you need to work on integrating and developing the corresponding register access test cases. So I'm talking about this thing which is common in all the projects. So this would give you that exposure how to go about the register model development, integration, and test case development. Then we'll also focus on front door and back door access test case as part of the register model only. Then we'll also learn how to develop functional test cases. Then we will, during this training, we will learn how to do the functional test case debug. I mean, let's say some test case is failing. How do we approach the debug? Like one is using RTL files, one is using the data flow window, one is using the schematic. So what are the different ways of debug we'll be learning. So since USB core is a little complex design, so you will get a good debug exposure as part of this course. We'll also learn how to implement the scoreboard. Means you know what is scoreboard. Here we'll be learning how to use the scoreboard. I mean, how do we use register model in the scoreboard implementation. Then once everything is done, once you have developed all the functional test cases, we will learn how to implement the regression flow using the TCL script. Then once the regression flow is set up, we will learn how to generate functional and code coverage report. I mean, how do we generate the coverage reports? And then we will also analyze the coverage report. I mean, what are the hits happening, what misses are happening, I mean, what coverage points are missing, getting missed during the simulations, and how to cover those holes we'll be discussing. That is what developing uh, more test cases for coverage closure is also one thing we'll be discussing about. So this is the overall training agenda. As you can see, we divided training agenda into two parts. One is learning the protocol related concepts. One is learning the USB core functional verification using system verilog UVM. Uh, let us, before we move into the protocol, let's understand one important point related to USB versions. I would rather say standards. Okay. You see, USB stands for Universal Serial Bus. USB 4 is the latest version, our latest standard. Now the question comes to you, most of you, is it useful to learn USB 2.0? I mean, if USB 4 is the current version which is being used in the industry, or either you would be working on USB 3 or USB 4 in many of your systems. Let's say you're using a laptop, the port that you might be using, you're using might be USB 3 port. Okay, then the question comes, is it useful to learn USB 2.0? So the important point is, it is essential to learn USB 2.0 before learning later generations. See, it's like USB 3 is built on top of USB 2. USB 4 is built on top of USB 3. So hence, it is essential to learn USB 2.0 before learning the further generations. Most of the basics remain same. I mean, most of the fundamental concepts in USB 2 and USB 3, USB 4 remain same. I mean, how can we understand it? Let's assume you have a device which is based on USB 2 and you are connecting it into USB 4 socket. Tell me, can someone tell me, does it work? If I connect USB 2 device into USB 4 socket, does it work?
I think is a backward compatibility supported.
It works. Okay, that is because
Yeah,
of
it's work.
backward compatibility. So the concept of backward compatibility comes here because both of them have common things. I mean, common concepts that they both support. So that is what we are talking about here. So that means for you to learn USB 4, it is important for you to start with USB 2, then USB 3, then USB 4. Okay. So that is the reason we are taking USB 2 here. Next. What are the benefits of USB protocol? I mean, why USB is important? It is because of the benefits offered by the USB protocol. What are the benefits offered? Is first thing is ease of usage. I mean, if I ask you, you have been using, all of you have been using USB for a long time. What would be the benefits? Can someone tell me what do you think are the benefits of the USB protocol? Can someone tell me? I mean, you have
We
been
can
using
take it.
USB.
It is portable. We can take it to anywhere,
Okay, yeah.
and we can
What else?
add multiple devices, multiple cables to one USB.
Yeah. Okay. Thank you for that. Any other reason why you, I mean, any other advantages of USB? Okay. Fine. Let us discuss. There are multiple benefits of USB. So let's start with some of those things. The first benefit is the ease of usage. I mean, USB based devices are very easy to use. First thing is called as plug and play. Plug and play means what? You just, without restarting your laptop, you can just connect your pen drive and you can remove the pen drive. You don't need to restart the laptop. In the earlier generations, I mean, in the earlier types of peripheral this protocols, like RS-232. See, before USB was invented, RS-232 and PCI kind of protocols were used for peripheral connections. What is meant by peripherals? Let's understand. For a laptop, mouse is a peripheral. Peripherals. Now to connect, let's say this is my laptop, this is my pen drive. I need some medium through which they both connect, right? They should connect through some medium. That is called as the interface. So that interface is based on which protocol is what we are talking about. Now this interface could be based on RS-232 protocol. It could be based on PCI protocol, not PCI Express, okay, PCI protocol. Or later they move to USB protocol. There could be many such protocols which could be used to implement communication between your host device and the host and the device. I mean, two components. You want to connect a peripheral into system. So what are the different ways? So earlier we had two types of protocol like RS-232 and PCI. Later they invented USB. Okay. Uh, the reason they invented is majorly the ease of use. First thing is plug and play. Means, does it mean that RS-232 is not plug and play? Yes, it is not. Means whenever RS-232 or PCI device is connected, the system needs to be restarted, which is not required in USB case, USB connections. Do you restart your laptop whenever you connect pen drive?
No.
We don't restart, right? Yeah.
Yes.
Second is portable. You can see the devices, the pen drives, which are very small in size, and they can be carried easily. They don't take much area, all that, right? And no need of, most importantly, they don't need any external power supply. You understand what do I mean by that? See, you have a pen drive. Do you use a battery inside a pen drive? Do we use any kind of cells, 5 volt or 10 volt cells in the pen drive? No,
No.
right? We don't use.
No.
Then where does it get the power from? See, it needs a power, right? It also consists of some memory cells and transistors, essentially. Even your pen drive, if you go down to the very basic level, what is it? It's a silicon which has got some memory cells and some flip-flop, some transistors. So for all this memory and transistors to work, it requires a power. So where does the power come from? If you don't use a battery in pen drive, where does the power come from to the pen drive? Can someone tell me?
From system, like we have connect to laptop. So
Yeah, basically what happens is, if this is my laptop, if this is my pen drive, okay, there are four wires connecting them. Okay, one is V plus voltage, one is ground. These two will carry the current, required voltage, required power or current to the pen drive. So the pen drive will use this current that is coming from the laptop to implement its operation. I mean, for it to activate its transistors and memory, it will use the power that is coming from the laptop itself. It won't have any of its own power. There are scenarios where what we call it as auxiliary power, where you could connect a power source, but in most of the portable applications, you don't need to use any external power supply. Through the connection itself, it will work. Next, no dedicated interrupt for each peripheral. See, going Generally someone who has attended our Verilog training, uh, when you have studied interrupt controller, or even for other people who are joining into this batch as a separate course, you know that in every system there is a concept called as interrupt. The peripheral generates an interrupt to get the processor attention. Let me repeat. The peripheral keyboard, see, whenever I say peripheral, understand that we are talking about keyboard, mouse, pen drive, these kind of things. They generate interrupt whenever they need the processor attention. So going by that, if I have a system, if I have a laptop, if I connect 100 devices, that means I will need 100 interrupt lines. This is a difficult part, I mean, because processor generally don't have so many lines, so many interrupt lines. That is where what USB does is it merges all these interrupts into one interrupt only. It merges all of them. Let's say these are all some USB devices. It merges all of them and just sends it as one cumulative interrupt. So that means what? No dedicated interrupt for each peripheral. You don't need to allocate a dedicated interrupt for each peripheral. Then there is a concept called as auto configuration. What is meant by auto configuration? Let us understand that. See, the first time you connect, I think I have to use this diagram repeatedly. So let me just try it on the paint. So what is that we want to draw? One host, sorry, and you have a pen drive. This pen drive is connected to this one. There are four wires we discussed. What are the four wires here? Okay. So in this diagram, this I call as peripheral. Okay. This will call it as host. This will call it as peripheral. These are the connecting wires you can see. One is the um V plus, I mean voltage V plus voltage VDD. One is the ground. One will be D plus and D minus. So this line is called as D plus. This line is called as D minus. What is D plus D minus also? I'll explain. Differential signaling. Differential plus, differential minus signaling. Okay, I hope you got a very basic idea about how it works. Now, what is meant by auto configuration? Let's understand what is the concept of auto configuration. See, whenever a peripheral is connected into laptop host, I won't use the term laptop. I'll use the term host. Okay, because host can be my desktop, can be a mobile phone, can be a laptop. So host is anything to which you connect your USB device. The host needs the peripheral drivers to identify the type of device, identify how to figure out how to work with it, how to work with the peripheral. Understand? See, anytime you connect your pen drive into the device, right, in the bottom here, it'll show one box. Generally, it'll pop up one kind of box here. You might have even noticed that in the bottom right corner, where uh, this device is connected. I mean, some Western Digital 1 terabyte hard disk SDD connected or HDD connected. You might have noticed that kind of thing, right? So we are talking about the same thing. So this work of identifying what is connected and how to work with it, how to do the transfers, how to read, is all done by something called as device drivers. Device drivers are part of the operating system. So every device, I mean my laptop, let's say if I take my laptop, has operating system. Inside, as part of the operating system, it also has some standard drivers. Drivers means uh, these are the embedded systems code, which has logic of how to communicate with peripheral devices. Communicate with peripheral devices. So whenever example, whenever I connect, let's say Western Digital 1 terabyte HDD device. So my system identifies, my host laptop identifies that Western Digital 1 terabyte HDD is connected. It it moves the corresponding device driver. Corresponding means what? The one specific to Western Digital hard disk drive into its RAM. Originally, it is present in its hard disk. The laptop hard disk. Laptop will have hard disk or SSD, right? SSD. So in one of them, it's present. So from there, it moves it to RAM. Then processor executes the instructions present in device driver to communicate with the device. I hope you got a basic idea. So what happened here? You've connected your Western Digital 1 terabyte hard disk drive. Laptop identifies that Western Digital 1 terabyte hard disk has been connected. It moves the corresponding device driver. See, device driver will tell how to work with Western Digital device. If it is, let's say, some other device, Samsung, some storage device is there, for example. Okay, there could be various types of storage devices, right? So it knows if it is some other device, there will be a different driver for it. That is what is the role of an embedded system engineer, to develop such kind of drivers which will help how to communicate with a specific device. Now, once the device driver has been moved into the RAM, okay, processor executes the instructions present in device driver to communicate with the device. So that is how the relay, that connection gets established between my host and the device. So this is how connection gets established between host and the device. Connection doesn't mean physical connection here. Connection doesn't mean just physical connection. Connection also means figuring out what driver to use, how downloading the driver. See, now you may ask, what is mean by auto configuration here? See here, auto configuration means my laptop identifies automatically. It installs see, sometimes what happens, sometimes my laptop don't have the driver, doesn't have the driver. It downloads it automatically, downloads and installs. And later, next time when we connect, it uses that prior installed Did everyone understood what is meant by auto configuration here? Did everyone understood what exactly mean by auto configuration?
Yes.
How about others? I get only one reply from so many people.
Yes, sir.
Yes, I got it.
Yes, sir. Yes.
Yes, sir. Yes, sir.
Okay, fine. Yeah. So this is means by auto configuration.
Yes, sir.
So the point is what? Any questions? Okay. So here we are trying to understand the benefits of USB protocol. First thing we started is plug and play. Second is portable. Third is no need of external power supply. Fourth is no dedicated interrupt for each peripheral. There is no need of dedicated uh, interrupt. Fifth reason is auto configuration. Sixth is, like one of the student pointed out, it is easy to add more devices into the topology. Now the question comes, I generally have only three USB ports, right? You may be seeing one USB port, one USB port, and one on the other side. This is what you will see. Typically, you're sitting in front of your laptop, right? Can you count and tell me how many USB ports are there in your laptop? Sometimes two, sometimes three, right? Not more than three. Then the question comes, we can only connect three devices, right? We can connect only three devices. Then how they are saying multiple devices? I mean, let me tell you, I can connect up to 127 devices. So using three ports, how can I connect 127 devices? My laptop has only three USB ports. Then how can I connect 127 devices using the three USB ports? Can someone tell me?
Using USB hub maybe.
Using hub.
Hub. There will be something called as hub, where here you can connect one more device, one more device, one more hub again you can connect to this. Like this you can create. Okay. So basically the answer for the question is, using the hub you can expand the number of devices you can connect into the USB topology. Next, uh, the most important benefit of USB protocol is the single interface for multiple devices. Okay, can you tell me, when I say multiple devices for different applications, can you tell me in what all scenarios you have seen USB connections are being used? In what all scenarios have you seen USB connections are being used?
Docker,
Docker, even printer, pen drive,
yeah,
mouse,
mouse.
music player, right? There are a lot of places it is used. So I instead of saying lot of places, it is used universally. Anything you want to, any kind of device you want to manufacture, any kind of peripheral that you want to manufacture, any peripheral you want to manufacture, the USB is the most preferred interface. You understand what does it mean, right? See, if I implement, if I want to implement a keyboard, keyboard can have multiple types of interfaces. Keyboard can have multiple ways in which it connects to laptop. One is using USB interface, one is using some standard keyboard interface. But this is always preferred. Reason is the benefits that it offers. All these benefit it offers. So that is what we mean by single interface. USB is the single interface, but it can be used for multiple types of devices: mouse, printer, music player, storage. For everything you can use it. Okay, now please understand that USB is the medium for high speed data transfer. See, it is not the actual function. Okay, so what do we mean by that is, if this is my peripheral, the peripheral is divided into two parts actually. The peripheral is divided into two parts. One part is the USB core, which implements the USB related functionality. Other part is actually the function, the function that we want from the device, the device function. What do we mean by that is, it can consist of microcontrollers or anything. Example, storage. Please be in mute. Someone is in printer, mouse, different things. Please be in mute, everyone. Prashant, can you turn off your camera? Okay. I hope you understood. Even when you take your pen drive, the pen drive can be split into two parts. The initial part of the pen drive, let's assume this is the pen drive, right? It will be USB core. The second part will be device function. It can be storage, it can be printer, it can be music player, it can be a mouse, anything. This is what is common in all USB devices. And this is what keeps different. If I take a music player will be having same common core. My music player will differ, because in earlier case it was used for storage purpose. In second case it's being used for playing the music. In another case, let's say you take a mouse, core will again be same, common. What will differ is the mouse identification, how it identifies where is the cursor pointed, whether to move right, whether to move left. See, I'm moving my cursor. So my mouse will identify. That identification logic is present here. Then you may say, what is the advantage of having USB here? I mean, question comes, if I remove USB, what is the problem? It will still work. Can you tell me what is the challenges if I remove USB? What is the problem? Assume that I remove USB core. What is the problem I'm going to face here? Okay. Okay, someone said slow transfer. Can someone tell me what is the problem if I remove USB? The problem is, if I remove USB,
Configuration.
not about configuration, I still need to do this connection, right? I still need to do some connection, right? How do you connect your device into the laptop? You need some connection. Now the question comes, this could have been USB, this could have been SPI protocol, this could have been PCI Express protocol. You could have used any protocol here. But the point is, USB gives the most maximum amount of flexibility. USB gives the maximum number of advantages, benefits. See, we could in fact use SPI also. Let me tell you, to implement your storage device, I could use SPI protocol here, and I could implement SPI core here and the remaining device function. I could even use PCI Express. I could even use AXI, for example. But AXI I can't use because it's outside peripheral, so I can't use AXI. I can use any of the peripheral protocols. But the point is, USB is the one which suits best for my requirement. So the point you need to understand is, USB is just a medium for high speed data transfer. It is just providing that platform, or it's just providing the medium for high speed data transfer. Did you understood what we mean by medium for high speed data transfer? USB is not the actual functionality. USB doesn't mean a mouse. USB doesn't mean a printer. USB doesn't mean a music player. It is just making sure that by using this USB medium, by using the, see here also USB logic will be there. We are transferring data from one USB to one another USB. Okay. Once it is done, Then the data is further given into the device function. The device function will understand how to handle the data coming in. See, the data will go from USB core to the device function. Now my device function will decide how to handle the data coming in. So essentially what is happening, somewhere there is a storage is there. We want to transfer this data from here to here. That is our goal actually. Point is, this data transfer could be done through SPI protocol, could be done through UART protocol, could be done through USB protocol. There are various protocols, but for most number of applications, USB is what is suitable because of the various advantages it offers here. You can see it offers so many advantages. Because of that, USB is the preferred choice for peripheral implementation. Okay. Please also understand that USB core implementation is isolated from function requirements. See, USB core is separate, device function is separate. Next, the other benefits of USB protocol are it offers speed. See, can someone tell me what is the speed of USB devices that currently what is the best speed that we can get in the current USB standards? Can someone tell me? I think the best speed will be
I
coming
think
from USB. Yeah, tell me.
5 giga per transfer.
5 gigabits per second is a long back. Tell me, what is the current one? Actually, it moved to 10, it moved to 20, it moved to 40. Now we are at
40.
80 gigabits per second. Speed is at 80 gigabits per second. That is in USB 4 standard version 2. There is a USB 4 itself has version 2. In that we get up to 80 gigabits per second. You can imagine what is 80 gigabits per second. Just keep a movie file for download. It should download in less than a second. That's what we are talking about. Okay, so that is the speeds we are talking about. So that kind of speeds you can achieve with USB, and the cost is low cost, right? You have seen, I mean, pen drives these days comes in hundreds of rupees only. So that is all because of the low cost of implementation of the USB and low power consumption. You might have seen that if I connect pen drive and start using it, even after 10 minutes it doesn't heat it up much. You will see that it won't get heated up much even after 10-15 minutes of uses. That is all because of the way it has been implemented to consume low power. It consumes the low power. Why, how does it consume low power? Tell me, what do you think they would have done to reduce the power consumption? What is the logic do you think they would have used to reduce the power consumption? Can you tell me?
It's like identifying the functionalities and accordingly the corresponding will be activated, remaining kept low.
See, the first thing they have done is they have moved to lower voltage, 5 volts or even less than that. Second is, whatever current they pass from here, they pass in milliamperes. They pass something like 500 milliamperes. Okay, that is one thing. I mean, by reducing the parameters itself, reduce the voltage and reduce the amount of current you pass. That is the first thing. Second is by using the concept of suspend operation. I mean, when you don't the device is not being used for a specific period of time, they put it into suspend state. When you suspend the device, what happens? The power consumption will be significantly reduced. So USB devices generally works on a 5 volts and consume current in milliamperes. Suspend mode is used to reduce the power consumption. Then the reliability. You know what is it mean by reliability, right? You throw the you I mean, let's say you drop your pen drive, you still connect, it will still work. Let's say you drop your pen drive onto the ground and you take it and you can still use it. So basically that is one aspect. Second aspect is When it comes to the reliability at the protocol level, you can easily catch the errors. Let's say I'm transferring some packet from here to here. Some error happened. There is a mechanism through which it can notify that the packet did not come correctly. It will send some kind of NAC kind of packet. So it identifies that whatever packet I sent, it got corrupted. So it will retransmit that packet and then it will be used here. So this mechanism is also there where you catch the errors, device can catch the errors, notify the transmitter to retransmit the data. Okay. So these are the various benefits of USB protocol. Let us quickly revisit all the benefits. During this revision, if you have any questions, please feel free to ask. So what are the benefits? Okay. First thing is what? Plug and play. What is second benefit? Can someone tell me?
Portable.
Portable. Okay. Third is what? No need of external power supply.
Yes.
Okay. Next is no dedicated interrupt for each peripheral. Fifth is auto configuration. Sixth is easy to add more devices into the topology. Seventh is using same single interface, you can support multiple types of devices. Then next is what speed it offers. Speed translates into the high bandwidth, right? Then low cost, then low power consumption, and the reliability of the protocol. So these are the various benefits of the USB protocol. Do you have any questions?
Already,
Any
like
of these
we,
things you want?
I'm audible.
Please tell me. Yeah,
So like, PCI is a on-chip protocol. So this is not. I think this is not a on-chip protocol.
PCI is a peripheral. PCI is a on-chip protocol,
Protocol.
but
Correct.
it is
So
used
it
for
is
connecting the peripherals.
correct.
Yeah,
Correct. I think USB is used as a for external, right? So I think
yeah.
this is not a on-chip protocol, right?
USB is not a on-chip protocol.
Okay.
Yeah. Any other questions? Okay, so let us move on to the next slide. What are the protocols that were used before USB? See, USB came into picture only around late 1990s. Okay, before that, what was there? RS-232 was there, PCI was there. I mean, if anyone has used the systems at that time, there was no USB in the late 1990s actually. Only around the 2000 time frame USB got invented. Okay, so before that we used to use RS-232 PCI kind of protocols to connect. It has this protocol had lot of issues. I mean, issues are mostly these things only. They were not plug and play. Okay. Need of external power supply probably was not the case. They could, I think they require external power supply. They needed external dedicated interrupt for each peripheral, so there were a lot of problems with the previous protocols that were used. To solve those issues, USB was invented. Basically, USB is invented to solve all those issues that were there in these kind of protocols. Next, what are the various USB standards? See, USB is released in four major standards. I would see sometimes I'm using version standard, both are same. Okay. Can you please go through these ones? What are the various standards? I hope you have gone through it. Basically, you see, USB standard was first released in 1996. That standard was called as USB 1.0. It supports low speed. That was called as low speed. You can see various terminologies here. First thing, low speed, full speed, high speed, super speed, super speed plus. Okay. Then later generations are called as enhanced super speed. Okay. So how these further differ, we'll discuss. One thing you can notice is till here there was no relation in the way speed changed. Let's see. It increased 8 times. It increased 40 times. Okay. From here you can see one relation. What is the relation between these things? Can you tell me? Starting from USB 3 onwards, there is a relation that is followed from one version to the next version. Can you tell me what is the relation you see in the
Double
speed?
line,
It
sir.
was doubled.
It is
Doubled.
getting doubled. That is how these protocols are always implemented to be. Let's say tomorrow they come up with V 3.0, they would result in 160 gigabits per second. That is how the protocol is implemented to be like. But here they didn't had any such rule, such standard. They went by what protocol would be able to support at that point of time. So this is where we have various USB standards. I mean, any USB you take, any device you take, it has to fall into one of these categories. It has to be either USB 3.0 device, it has to be either 3.1 or USB 4 or USB 2.0, one of them. So USB 1.0 was released in 1996. It supports low speed signaling, and the low speed is nothing but 1.5 megabits per second. Then in 1998, they released USB 1.1, which supports full speed. The full speed refers to 12 megabits per second. Then in 2001, they released USB 2.0, which supports high speed 480 megabits per second. In the same time, around same time, they released revised standard of USB 2.0, but both of them are same. But they still work at 480 megabits per second. After 7 years after that, you can see, after 7 years after that, in 2008, they released USB 3.0, which supports super speed, and it is Gen 1, super speed Gen 1. So USB 3.0 itself has multiple generations, right? Gen 1, Gen 2, Gen 2 cross 2. They have used different naming conventions. So USB 3.0 supports 5 gigabits per second. Then after 5 years, that is in 2013, they released USB 3.1, which supports 10 gigabits per second. In 2017, they released 3.2, which supports 20 gigabits per second. It was called USB 3.2 Gen 2 cross 2. See, the naming itself is called as USB 3.2 Gen 2 cross 2. That is how you name it as. Then in 2019, they released USB 4, which is Gen 3 cross 2, okay, which supports, means it's like generation 3, third generation. This is the second generation. This is the first generation. Now you may say, what is cross 2? I will explain. Cross 2 means two lanes. See, cross 1 means only one lane. It's like, I'll tell you, simple example. You have one container, you have another container. You're moving some liquid from here to here. Only one lane if you use, it is cross 1. If I use two lanes, one more lane, that will become cross 2 totally. So what is the advantage of having two lanes? I'll be able to send more liquid from here to here. Same thing here. When I use cross 2, the speed automatically doubles. See, whatever you would get in the previous generation, you would automatically increase the speed. Now, here also you see it's a cross 2. Here also it's a cross 2. Then how did the speed double here? It doubled because this standard works at a base speed of 10 gigabits per second per lane. So this standard works at 10 gigabits per second. Because of cross 2, what will happen? Overall effective rate happens what? See, the USB 3.2 works at 10 gigabits per second. When I do cross 2, what is the effective rate? Can someone tell me?
20.
20.
20 gigabits per second. So that is how they did. Now, super speed plus, let's take this one. What do you think is the speed that is used here? It is when they don't give any cross 2 means it is cross 1 only. If they don't say any cross means it is cross 1. So what do you think is the speed supported in super speed plus?
10 giga.
10 gigabits, right? Because whatever is the speed you are getting, that is coming from one lane only. It is 10 gigabits per second. Tell me, super speed refers to what speed?
5
5
gigabits.
gigabits.
5. Do you think is it cross 1 or cross 2? Is it one lane or is it two lanes? See, cross 1
1
means
lane.
one lane, cross 2 means two lanes. Now tell me, super speed refers to, in this example, what you see, is it referring to one lane or two lanes?
1 lane only.
It refers to one lane only. So super speed plus C, then what they did is from 5 gigabits to 10, they moved to a speed where they started supporting 10 gigabits per second. They didn't want to use some new name, so they used super speed plus. Okay, this is also on super speed plus only, but only thing is it is using two lanes, so hence speed is doubling here. Then they moved to a new generation where they started supporting 20 gigabits per second. That they called as enhanced super speed. I mean, see, they have used different naming terminologies. So 20 gigabits per second into 2, they will give 40 gigabits per second. Okay. What do you think would be the speed of version 2 here? The per lane speed of version 2.
80 gigabits.
No, it will be into 2. It will be by default, it will have two lanes only. So base speed will be 40 into 2, 80 gigabits per second. Okay. So in summary, there are different naming conventions in USB. First is low speed, which works at 1.5 megabits per second. Next is full speed, which works at 12 megabits per second. Next is high speed, which works at 480 megabits per second. Next is super speed, which works at 5 gigabits per second. The next is super speed plus, which works at 10 gigabits per second. Next, they don't name it, but let's call it as, I think it is called as enhanced super speed, which will work at 20 gigabits per second. So on. I think what is the short name they have used? I think they will use the name USB 4 Gen 4. Or instead of calling as enhanced super speed, let's call it as USB 4 Gen 3 cross 2. That is how we should always see it as. And this should be called as USB 4 Gen 4, which works at 80 gigabits per second. So finally, what is that you have achieved out of all this is when you move from here to here, the rate has increased by how much times? And how much times
Double,
the rate has increased?
double.
No, 1.5 to here.
Oh, okay.
6 times, sir.
So many times, some 600 into, not 16 times, this is megabits per second, this is gigabits per second. Okay, almost 50,000 times the speed has been increased. Just you divide 80 gigabits per second by 1.5 megabits per second. That's the kind of speed that has increased. Even forget these two, moving from here to here itself, they have increased so much. Anyway, let's not get into the comparison of all this, but I hope you got an idea what are all various USB standards are there, what we mean by low speed, what we mean by full speed, high speed, and super speed plus. Any questions in this slide?
Sir, any issues with the power as data rate is increasing?
Any? Please repeat your question.
Power, sir, power related issues while increasing these data rates.
Yeah, when they increase the data rate, automatically power consumption will increase, they will have a ways to handle it. Issues will not be there. They will implement the device in such a way that power dissipation can be done.
Okay, sir.
I have one question, Adi. So I think
Yeah.
USB speed is more than compared to other product like PCI, Ethernet, right? Ethernet also
No, Ethernet is 400 gigabits per second is there now.
400.
Yeah, Ethernet gives up
PCI
to
is 16,
400
right?
gigabits per second.
PCI is
PCI also
16
gives
gig.
you similar speed. PCI gives up to PCI, I think Gen 6 will give you 128 gigabits per second or 64 or something. It should give 64.
Okay.
Yeah,
Okay.
they're all
Lower.
equally there close by. Yeah. Any other questions? So the point I'm trying to tell is all these protocols uses some common standard called as OSI reference model. You might have studied 7 layers: network layer, application layer, transport layer, link layer, physical layer. They use similar kind of concepts. So because of that, they're able to upgrade the speeds every few years once. Same thing happens in PCI Express also. Any other questions?
Sir, can clarify that interrupts related. This can handle multiple interrupts and something this.
No, what I mean by that is, see, in USB, no dedicated interrupt for each peripheral. See, what happens is, what is the need for an interrupt? A peripheral uses interrupt to get the processor attention. When in a general convention, when we have 10 peripherals, we need 10 different interrupt lines. See, simple analogy of interrupt is like you're asking me a question. So you are interrupting the session to get my attention so that I can answer your question. Same way, whenever peripheral wants processor attention, it generates an interrupt. If there are 10 peripherals, we will need 10 different interrupt lines. Whereas in USB, so as we increase peripherals, as we increase peripheral lines, interrupt lines, processor interface gets complex, right? Gets bigger because you need to support so many wires. So in case of USB, all connected peripheral interrupts are collected by USB controller and it sends it as one interrupt to the processor. So the advantage is we don't need to use many interrupt lines. Now you may say, how can it work with only one interrupt line? That is something else we'll discuss later. For now, just understand that without using many interrupt lines, but just by using one interrupt line that is going from controller to the processor, we are able to manage all the peripherals. Did you understood now? Did you
Sir,
understood what?
sir, here all connected peripheral interfaces in the sense we're talking about the USB hub, right? Because that
USB hub,
USB
yes,
hub.
yeah. Basically, whatever you connect, let's say you connect in a topology. I'll show you one topology diagram here. Let's say this is generating one interrupt, for example. This will generate an interrupt. Like different generates an interrupt. All of them are merged in the controller, and they will send it as one interrupt to the processor. Okay, how the merging happens and all that, let's discuss later. Okay, in other cases you need a dedicated line, one line for each peripheral. So many lines has to go to the processor. Instead of that, what we are doing, we are merging all of them into one single line and giving it to the processor.
Sir, it's like enumeration, sir.
Enumeration is different. Enumeration is different. We'll discuss what is enumeration. It's like, what do you say? Merging all of them into one single interrupt. I don't know what is the complex word for that. I'm telling in the simple words. We are just merging all interrupts into one single interrupt.
So
Clear to you?
device will be
Oh,
identified
okay, sir.
by, hello.
Yeah.
So device will be identified via interrupt vector ID. Like interrupt vector ID is different,
We'll
is
discuss
unique
that
for.
part also. Yeah, based on who generated the interrupt, there will be an address that is assigned to it. Based on that, it will be identified who generated the interrupt. Each of them will have one dedicated address. Let's say address 1, address 2, address 3, 4, 5, 6, 7, 8. So when the interrupt packet comes from 8, it knows that eighth device is generating the interrupt. So my driver knows that interrupt is coming from device 8. So there is a mechanism through which processor will get that information, and it knows that I have to service device 8.
Sir,
This
one
case
more
what?
question. As per, uh,
Yeah.
sir, as per this CSB concerned, interrupt means data transfer only, right? Any other kind of
Interrupt,
interrupts?
interrupt doesn't mean just data transfer. Interrupt can be generated just because I plugged it in. Interrupt will be generated. I remove it. Interrupt will be generated. I switch it off. Interrupt will be generated. I do some wrong type of transfer. It will generate an interrupt. So interrupt can be generated for many reasons.
Okay, sir. Okay.
Any other questions? So let us now we have seen various USB standards. Okay. Now let us try to understand some of the USB protocol basics. First thing we need to understand is USB is a host centric protocol. What is mean by USB? What we mean by host centric protocol? Let us try to understand. See, in USB, all transfers are scheduled by the host only. Any transfer that happens in USB, it is scheduled by the host. Let's say you connect pen drive into your laptop. Can you tell me what is the host there in that example? Who is the host? When I connect pen drive into the laptop, who is the host in that system?
Laptop.
Laptop is the
Laptop.
host. So it is the laptop which will schedule all the transfers. My device will not have any control on that. Function means device can only indicate their condition. What is my condition? It can say that I am busy right now, I cannot respond back to you, or it can say that I got into some error condition. It can only tell it can tell its condition, but devices cannot initiate any of the transfers. They can only respond back to the request. It's like my host will send the information to that, my device will respond back. Even to say that I'm busy, even to say that I'm in error condition, host has to ask what is your condition, in what condition you are in. The host has to initiate that also. That is why USB is a host centric protocol. Next. I hope you understood why we call USB is a host centric protocol. USB is tiered star topology. Tiered means what? Multi-tier will be there. Star topology. Let's understand what is meant by multi-tier star topology. Can you understand this diagram? How does this diagram look like? This is called as tier 1, first level. This is called as second level. This is called as third level. This is called as fourth level. These are the fifth level of devices. Can you see that tiered topology? And it looks like a star, right? So the connections looks like a star. That's why it is a tiered star topology. And how many maximum number of tiers can be there? Levels can be there. 6 levels can be there. I mean, you cannot connect 7 levels of hubs. You have to fit everything into six hierarchies. Next, Did everyone understood what we mean by maximum number of tires is 6 only? That I have drawn something like this, right? The maximum level that you can go is 6th level. Beyond that, you cannot go. USB doesn't support it beyond that. Supports plug and play, we discussed. You can connect up to 127 devices to any one USB bus, including the hubs. You can connect up to 127 devices. You may ask, where does that number 127 limitation comes in from? That is because to identify each device, to identify each device, USB host assigns a 7-bit function. Please be in mute. Please be in mute. Someone waiting for name. Please be in mute. A USB host assigns a 7-bit function address, in short called as a fail. Using this 7-bit address, 7 bits means what? 128 value, 128 possible values. 0 is always reserved. 70B00000 is reserved. Cannot be used for any devices. So that means 127 values are left. Hence, maximum of 127 devices can be connected. This includes the hub also. See, hub is also counted as a one device. Any hub that you connect is also becomes one device. That is where up to 127 devices can be connected into any one USB bus. Host controller, see, you may ask, do you really see that there is a need to connect 127 devices? Do you think in your laptop or any complex requirement, will there be any need to connect 127 different devices into a laptop? No, right? Generally,
No, sir.
unless in normal all use cases, you connect only 2, 3, or maximum 4, 5 USB peripherals, not more than that. Next, host controller is connected to the hub integrated within the SoC. Host controller means here the USB controller we are talking about. The hub allows number of attachment points. It is the hub which allows maximum other USB devices to be connected into. And in case of USB, the length of any cable is limited to 5 meters. See, after 5 meters, what happens is the signal degrades. The one seats here in USB, even though you are sending ones and zeros, it's not going to go like this. It's not going to go like this. It is going to go like a voltage. It's going to go something like this. Okay. As the length of my cable increases, finally by the time it reaches the destination, the quality of the signal would have got degraded. Something like this, where you can't identify whether it is 1 or whether it is 0. That identification itself becomes difficult. Hence they limit the length of the cable to 5 meters. Next, in our terminology, laptop indicates host, pen drive indicates a function or a device, hub indicates the interconnect. Now, if you have only one device to connect, you can directly connect host and function without any hub. But if you want to connect multiple devices, you have to use the hub. Okay, so this is a brief about USB protocol basics, nothing specific to 2.0. Okay. We have already discussed why USB is called as host-centric protocol. Let us talk about some more USB 2.0 basics. Okay, as I said before, a device cannot initiate a transfer, but must wait to be asked to transfer the data by the host. See, everything has to be initiated by the host. The only exception to this is when device has been put into suspend mode. Okay, by the host, then the device can signal remote wake up. See, the only place where device has some control is waking up from the suspend mode. Let's say it is put in suspend mode. So since it is put in the suspend mode, it cannot understand anything coming from the device, right? It's like this device has gone into suspend mode. It has to say that remote wake up. Then host understand that I have to wake it up. Okay. So that is the only exception. Otherwise, everything is initiated by the host only. And talking about USB 2.0, it supports three speeds: low speed, full speed, and high speed. See, the way you should understand is this speed will be supported in this version. These two speeds will be supported in this version. This speed will be supported in super speed. Super speed will be supported in super speed plus configuration. Like that. They do that to maintain backward compatibility. If you say that I am on USB 3.1, I won't support previous generations, what will happen? I cannot use this in multiple devices. So to make sure that we don't do that, we have other devices can be connected. The USB implements the concept of backward compatibility. What is mean by backward compatibility? Let us try to understand. Can someone tell me what is backward compatibility?
Backward compatibility means it supported the old feature, correct?
Yeah, ability or one standard of device or version of device to connect with previous version of device, both in terms of hardware compatibility and the software compatibility. I mean, what is meant by hardware compatibility is I should be able to plug in, right? If my pen drive is my laptop is there, my pen drive, they all should have similar kind of connector size. Say when I go from USB 2 to 3, they should not change it. They should still keep the same size. When I go from 3 to 4, they should still use the same size. Otherwise, what happens if I increase the size? I cannot fit it in. Okay. The one example where the compatibility is not supported. Let's understand. Let's take example where backward compatibility is not supported. Can you give me one such example? We use it every day. It's present in all your laptops. Whatever I'm talking, that where backward compatibility is not supported, is there in it's all there in your laptops. Can you tell me one of such example where backward compatibility is not supported?
Sir, DDR RAM.
Yeah, DDR is the best example of where backward compatibility is not supported. That means what? DDR2 memory can't be connected to DDR3 controller. Vice versa. DDR3 memory can't be connected to DDR2 controller. All these possibilities are not there because why they don't support is the pin count differs. The DDR2 has a different pin count, DDR3 has a different pin count, so hence they don't support at all. In USB, that problem itself is not there. They have made sure that compatibility is taken care. What is mean by that? A USB 2 device can be connected to USB 3 socket without any issues. Tell me what speed they will work at. Will they work? What speed they will work at in this case? Will they work at USB high speed or super
Oh,
speed?
that
Can
is
you tell me? In this example,
high
will
speed
they
one.
work at high speed or super speed? They will work at high speed. That is nothing but the USB 2 speed. Because lowest they will pick. Whichever is the lowest, they will pick. The hardware compatibility means what? Physically they should be able to fit in. Software compatibility means what? Whatever packets and frames supported in USB 2, USB 3 also should support. That is called as software compatibility. We have already discussed USB 2.0 speeds. Okay. Let us try to understand the USB topology. USB topology is called as tiered star topology. See, host connected to multiple devices through the hubs. 127 devices per controller. One controller can support up to 127 devices. Please take a look at this once, how this looks like. So this is where the host is present. Host is part of my laptop or my mobile phone. Even host could be my mobile phone itself, could behave like a host. This is present in my laptop or mobile. So this is a USB cable. To that you connected hub. Again, these are all USB cables. These lines you see, they're all USB cables. This is how some of the connectors looks like. You might have seen two types of connectors. One where which one do you think is there in your laptop? Type A or type B? Can you tell me?
Type A.
Type A.
Type A will be there. In some other devices, there will be type B receptacles will be there. A receptacle point downstream from host or hub, while B receptacle point upstream from device or hub. So we'll discuss what is meant by downstream, what is meant by upstream. We'll discuss all this in the next session. So right now, what we will do, we will stop the session here. We will take up some of your questions. Then we will end the session. So I'm done with the whatever demo part I wanted to do for today's session. I wanted to just give you a brief about what is the USB course, what all things will be covered, a brief into USB protocol. In the next session we'll be going deep into USB 2.0 features, like what is meant by device detection, speed negotiation, what is meant by enumeration, what is data transfers, suspend and resume. We will study USB 2.0 protocol in depth, including low speed transfer, full speed transfers, high speed transfers, split transactions. Everything we'll be talking about. Once we are done with the protocol, then we will be going into the USB core functional verification. So we will stop. Any questions you have?
Already, we have
Yes,
discussed.
hi, sir.
Yeah,
Yes. Hello. Sir, in
yeah.
USB 3 also support up to 127 device, but why increase tier in USB 3 7 tier, right?
7 tier. I need to understand. I'm not sure why they have made it 7 tier. I need to understand that part. Right now, I don't have answer for that. I need to check that.
I have similar questions, sir. What is star topology? Can you explain it once again?
Star topology means, see, how does a star look like? Like this, right? See, star looks like this. They are assuming like a looking like a star, right? So this is one star. From here you take another thing. This another star kind of topology.
But maximum we can connect 127, right? So like in star topology also we have to connect only 127, or like it is
That's what 127. No,
uh,
no, 127 only. See, this is 1, 2, 3, 4,
oh,
5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Like that up to
like in the
127
okay,
maximum.
okay.
Because it
Even
looks
even
like
if it
this,
is a
it is called a star topology. Yeah,
okay,
please tell me.
it means even it is like 6 layered, if we can connect 127 only, not more than that.
That
Whatever be the case, in you up to USB 2, you can connect six tires. So this is one tire. I'll tell you. This is tire 1. This is tire 2. This is tire 3. This is tier 4, this is tier 5, this is tier 5, tier 6 maximum. Beyond that, you cannot connect anything. You cannot have hub and device. It is not possible because that will become 7 tier.
Sir, one
Okay, like
hub,
someone pointed,
how,
yeah, tell me.
sir, one hub, how many maximum support device? And
That is, I think, depends upon the hub, how the hub has been implemented. So I mean, again, you can search. I don't remember that numbers actually. Maybe they may support up to 16 devices maximum.
If you use more devices, so I think load will be increased. Fan in, fan out will be increased. Right? Consumption also will be more. Right?
That's what, see, hub, yeah, that's what I mean. If I use too many devices, it will increase the load on the hub, and that impacts the hub performance. Maybe we can search what is the maximum supported also. Maximum downstream ports, USB hub. Um, no more than 4 downstream ports. Yeah. Got it right. Up to 4 downstream port you can connect in the hub. Any other questions?
Yeah, hi sir.
So
You can even post your questions in the chat window if you want to.
Uh,
Yeah, please ask.
so, yeah, so sir, now, like how much we will charge for this course, this USB for verification?
You see, USB core verification, I think it should go for around 6 weeks. I'm assuming. Though I said 5 weeks, it will go for 6 weeks. I mean, if you go for live training, I said 11K plus GST. If you go for e-learning, where you just go with the recorded videos, it costs 9K plus GST.
Okay, sir. Thanks.
Never did any next question is, never did any functional verification project, so this will be from scratch. I'm able to do so. What are the prerequisites required? Prerequisites are what person should be very good with SV and UVM. Other than that, no prerequisite. If you are good with SV and UVM, we can do entire functional verification project from, we'll be doing everything from scratch, but you should be good with SV and UVM. Yes, next.
Sir, I don't have any knowledge on SV and UVM. So
Then this course
how
will
how
not be
can it?
suitable for you. I mean, see, this course,
Oh,
one initial part you can learn. Let's say if you only want, you can only enroll for USB protocol only. The cost will be less
okay,
automatically. Okay, if you want to learn the
okay,
protocol. But if you want to
okay,
learn functional verification part of it also, then you should be good with SVUM. Otherwise, you will find it very difficult, the second part.
okay.
So suppose in future we learn that SP and UVM and we have to plan to buy this online course recording sessions. So can we go through that?
Yeah, you can do that. I mean, every session I'm doing, it will be recorded and it will be present, uploaded as part of the USB e-learning. You can get access to that.
Okay. Thank
So, sir, what type of test we are writing for these peripherals? Can you give some examples, like basically?
One second, I'll list down all the questions. Is will the same live lectures be in the e-learning? Yes, you will be getting the same live lectures.
Sir, along with the classes, I mean, if we miss any one day, will we get a video to
Yeah, yeah.
revise?
For every session, you get access to the video for 10 days. Every session you are
10.
going to
Okay,
attend, you will get access for
okay,
10 days. That is as long as people use it in a right manner. As soon as we know that people are misutilizing, then it will
okay,
be, the access will be discarded. Misutilizing means sharing
okay,
with friends or anything. Then access will be removed completely. Okay.
okay,
Next, host controller registrar programming will be done by RAL method. See here, we are not, our DUT, our design under test is not host controller. our design and the test is in our verification. What we are going to do, this is our DUT. So DUT having the UTM interface, the host interface, the function interface, and there will be one memory interface will be there. So my host will have three interfaces, one with the host, one is with the device driver, device function, one is with the memory. So for this we'll be doing the programming through the RAL. We'll be implementing a register abstraction layer, register model, through which we'll be programming the USB core.
I think
I hope it
so.
is
Real
clear.
method will be used, right? Yeah, yeah.
Come again.
So register programming will be happen via RAL method, correct?
Yes, we'll be using the RAL method to do the register programming. Yeah.
Okay.
Okay.
So simple
Next
programming,
question.
why, for we can program normal register programming. So why it is used RAL here? Any importance? Any?
When we go to the trial, you'll understand it. It's 1 minute is too quick to explain, too short time to explain why we use RAL. It's that itself in itself is a major topic. Industry uses RAL because it offers
Correct, correct.
lot of
Industry,
advantages. Yeah.
right.
So when we go to the topic, I'll explain you. But we'll be discussing all that. Yeah. Next is
Yes, sir. One
yeah,
question.
yeah.
If I choose e-learning, then also I will be having access to the tools and these kind of things, right?
Yeah, everything else will be same. Yes.
Okay, so the basic difference is I will not be able to attend the live session. That's only difference.
Yes, exactly. Yeah.
Okay.
See, sometimes you have some other commitments, so you don't attend live session. So we have this flexibility of e-learning.
Sir, can you tell about the test cases that we are using here?
Yeah,
Like,
test
just
cases. Okay.
example, like,
Basically, test case, what happens is when you go into the USB, you will understand that USB core supports something called as endpoints. Then there will be concept called as transfer types, like isochronous transfers, bulk transfers, control transfers, interrupt transfers. Then it uses transfer directions. Then endpoint itself consists of buffers. Okay. Internal to the USB core, there will be DMA, internal DMA. So our test cases will be focused on all these aspects. Doing isochronous type of transfers, isochronous in transfer, out transfer, bulk in transfer, bulk out transfer, control transfers, interrupt transfers, and different types of buffers. Then the test cases targeted for interrupt generation and interrupt handling. Okay, error scenarios, error handling, the USB suspend and resume. These kind of things will be focused in the test cases.
So will it be covered as part of USB protocol itself or
No,
separate?
yes, theoretical knowledge, yes, you will understand everything. You will definitely
Okay.
learn all this 85 slides. What you see is all theoretical only. There is no verification. Verification is a different presentation altogether. Even I will be
Okay.
improving it. See, right now it's 83. It may even go to 120, 130 slides by the time I am, every day I will be updating. So I'll be adding the new
Okay.
slides for that.
Okay.
this course is like, this is we are writing this verification codes only, or this DUT is already available and we are giving the test case only, or
DUT
we
is
are doing
already
both the
available.
thing.
No. Our RTL code is already available. For that, we are going to set
Okay,
up the
test
test
case.
bench. Yes.
Okay.
So,
Next, someone asked
sir, in
USB.
future,
Yeah, please ask.
post question in chat.
You have posted the question, is it? Okay. Wait, let me take it. Okay, someone asked a question. USB-C type is different from normal USB type. See, the form factor is different. What is form factor is the size gets reduced, right? See, this is normally how it looks like. C type looks like this much only. So that form factor will differ. Otherwise, they will be same. Okay. Uh, The form factor means the size. This is one form factor, this is another form factor. Otherwise the connections will be same, the number of wires that go, everything will still be same. Can we download e-lectures? No, of course no, you cannot download. Next is okay. Major difference between live and e-learning I have explained you. How many days can we access e-learning lectures? Generally e-learning lectures will be accessible for 3 months duration, and any chance of explaining, to explain post silicon validation front about USB, like validation of USB features. We won't go deep into it because post silicon validation is all about using the analyzers. There will be something Teledyne, or there are different types of analyzers, right? Analyzers, and getting the trace and analyzing the trace. As I told you earlier, I think over the phone call, we have some videos which explains, which goes into, which discusses this trace analysis, which talks about trace analysis. But this course doesn't talk about it because this course is not related to post silicon validation. This will be focused on pre silicon validation, that is on the functional verification of the RTL code. But
Okay,
you
sir.
would still get some
Uh,
useful insights into it.
But how much you will charge for the videos, sir, for the trace analysis and
We will discuss. Please call me afterwards. I need to understand how many weeks it will go. Accordingly, I can
sure, sir. Yeah.
tell you.
After
Next,
this meeting, shall I call or any time, sir?
please call after 4 o'clock.
Okay, sir. Thank you, sir.
Okay. Yeah. So, like you asked, hands-on sessions. I mean, see, there is nothing related to post-silicon validation. Yes, pre-silicon, I mean, the functional verification hands-on sessions will be there. It's not like I'm just going to teach. We'll have for every topic I do, there will be a corresponding lab session so that you practice the things and you learn the things. Idea is not that I should become expert with USB at the end of the course. I want participants to gain a good level of expertise with the USB. Next is, will there be live lectures of USB 3? I can't commit. Mostly, yes, we will be doing, because instead of USB 3, I will be doing USB 4. USB 4 live lectures will be there in next 3 months. After 3 months, I'll be doing the USB 4 course. Okay. I mean, we may include some USB
So
3 topics.
verification also only as
No.
only.
Only protocol. See, USB 3, USB 4, getting RTL code is not very easy actually. You don't get. So hence, it will be only on the protocol focused. Okay. Will there be live lectures? Okay, this course is useful for SOC verification. If you ask me directly as a SOC verification, will it help? No, because ours is a IP level verification course, means module level verification, right? So it will help you from a module level verification perspective, but then the concept of register model, the concept of debugging test cases, understanding the test case development, these concepts are useful for SOC verification also.
Sir, are we doing functional coverage, toggle coverage also here?
Functional coverage implementation, yes, we'll be doing, and functional coverage analysis, and we'll also discuss
So,
about how to add new test cases to close the functional coverage. Any other questions?
are we using any tool for this functional coverage, or
No, it's the
we are
same
implementing this?
tool. See, we use Questa Sim or VCS. Questa
Okay.
Sim. Mostly I use Questa Sim, or we can even use VCS for learning the functional coverage. I mean, for analyzing coverage, for analyzing coverage analysis. There is no separate tools generally for coverage analysis. The same tool can be used for coverage analysis and coverage closure. Okay. Next, for how many days do we have theoretical sessions and practical sessions? Generally, we will run it as two separate batches, weekend batches, full week batches. So I will tell you, weekend batches mostly will run from 9:30 to 9:30 a.m. till 6 p.m. I mean, first half theory, second half lab. We full week is a different schedule. I mean, we'll be having around 5 to 6 days per week. That we'll discuss. I mean, this how we'll have. I mean, I won't just be teaching theory. I won't just be doing things from my side. We will have some sessions where participants will be doing the hands-on labs. Then next, for how many weeks? I told right the e-learning material is accessible for 3 months. 3 months access. How tool access will be provided? Tool access provided for 1.5 months, or mostly 1 or 1.5 month. I'll tell you either 1 or 1. I think 1 month is where we do the critical activity. 1 month, because initial 1 2 weeks will be protocol only. 1 month and 24/7 access to the tool. Or we might extend it up to 1.5 months because we want to give you time to practice. Yeah, and you can access it anytime during the week. Uh, Same topic will be covered in, yes, same topics will be covered, same syllabus will be for both batches. How many clarification sessions? The clarification sessions will be on a need basis. You can will create a individual WhatsApp group where you post your request. There we will schedule a dedicated sessions to clarify all your doubts. Any other questions? It will be scheduled as and when you need. We'll schedule the sessions for doubt clarification. That sessions can be scheduled even for weekdays if you want, because so that you are not stuck with any doubts. Any other questions?
Sir,
Weekend offline classes.
apart
Yeah, Hima Bindu, please go ahead.
yeah, apart from pin changes or speed change, is there any difference between USB 2 and 4, sir?
Yeah, see, number
Any
of
new
pins have been
features
increased. Of
added
course,
or
see, USB 2 has only 4 pins. USB
yeah,
3 uses 9 pins. As you
yeah,
do cross 2, this 9 pins will be further increased, right? Because this is only with the
yes,
cross one. Cross 2 will of
yes,
course increase the number of pins. Other than that, see, USB 4, it's not special because of the speed change. It's special because of the concept of protocol tunneling. It supports various
okay,
other protocols like DisplayPort, Ethernet, various other protocols it supports. Because of that,
okay,
USB 4 is more uh, special compared to other previous
okay,
generation.
okay, sir.
Yeah, someone else had a question.
And offline classes is there.
Offline is also there. If you, I mean, every session you can attend in offline.
I mean, weekend it is there or not, sir?
Weekend also you can attend offline. Yes, weekend also offline sessions will be there.
Okay, from 9:30 to 6 like that.
Yeah, 9:30. See, one session will be offline. Other second lab session I won't commit, but theory session definitely will be offline. Any prior knowledge required regarding USB? No prior knowledge required. We are going to cover everything from basics. Even today, if you see, we have started from the basics of what is USB, the benefits of USB, the USB basic concepts. So no prior knowledge required. Any other questions? Okay, if you don't have any other questions, we will stop this session here. I told, right, lab sessions, I told for every theory session there will be a lab session, corresponding lab session. Only when we start the sessions I can tell you exactly how the lab sessions will be split. What is your question, Prasad? Here I said for every timings, I said, right, weekends means it will be uh, 2 p.m. to 6 p.m. or 5:30 p.m. kind of timings, weekends, the lab session. Weekdays, for weekday students, during the weekdays you can get access to the record if you miss it, session recorded videos.
Sir, I have one doubt, sir. So basically, for memory verification, we have some data, like we used to give some data to the scoreboards. But for peripherals, what kind of data, like how to fetch data in the scoreboard?
See, that's something when we go to the USB, we'll understand. Data means it will be all the transfers will be in terms of packets. We will learn how to collect the packets and how to compare the packet to packet level. That we will discuss in the USB scoreboard session.
Oh, okay.
It will be more, little complex, but we will make sure that everything is covered from the scratch in that. Any other questions? Okay. You see, next session will be tomorrow at 9:30 a.m. In case you are interested, you can go to this link and confirm your enrollment. And there is a process in this. That process will help you understand how to enroll, or otherwise you can call our manager or enrollment team. They'll help you with the process for enrollment. Yeah. Can we request clarification? No, we can even, you can post request in group, in WhatsApp group. The discussion can be live call. It can be in live call meeting. Any other questions? Okay, we will end this session. Thank you, everyone.